you in. All right, today we're going to take a look at radical equations. We're going to solve. For example 1, if I had the square root of x minus 3 minus 2 is equal to 4. On these type of equations, the first thing that you need to do is isolate the radical. So I need to isolate this radical x minus 3. So I need to transform 2 to the other side. Remember, the inverse operation for subtraction is addition, so I'm going to add 2, and that will give me radical x minus 3 is equal to 6. The next step would be to eliminate this radical symbol. In order to eliminate the radical symbol, I'm going to square both sides. And if you recall from a previous lesson, if I square a radical, I get the radicand. The radicand is the information under the radical symbol. So when I square this radical, I will get x minus 3. Square the other side, I get 36. Now I have a one-step equation. Transform the 3 by using addition. I end up with x is equal to 39. Now after you get your solution, you need to be absolutely sure that the answer that you have will satisfy the problem. So I'm going to take the 39, replace it for x. I'll have 39 minus 3, which is 36. The square root of 36 gives me 6, and 6 minus 2 gives me 4. So that x equals 39 is correct. That is the solution for the problem. Always check to make sure that your solution will satisfy the problem. Example 2. If I have the square root of x plus 5 is equal to x plus 3. Again, the first thing I need to do is eliminate this radical symbol. In order to do that, again, I'm going to square both sides. As I square this left-hand side, when I square a radical, I get the radicand. The radicand in this case is x plus 5. When I square a binomial, if you recall, the rule for squaring a binomial, square the first term. If I square x, I get x squared, plus twice the product of these two terms. The product of these two terms is 3x. Twice 3 is 6, so I get plus 6x. Square the last term, I get 9. Now, if you've forgotten how to use the rule, remember when you square a number, you multiply by itself. So if you need to, x times x is x squared. X times 3 gives you 3x. 3 times x gives you 3x. And 3 times 3 gives you 9. Combine the two terms in the middle, you get your x squared plus 6x plus 9. If you're using the rule, I talked through the rule, but to indicate, to show it to you, to illustrate it, the rule that I used, I squared the first term plus twice the product of the two terms, and I took the last term and squared it. So I get x squared. X times 3 is 3x times 2 is 6x, and 3 squared is 9. Now, as you notice, I have a quadratic term here. I don't have a way to get rid of it, so that indicates to me that I need an equation that is set up to be equal to 0. So I'm going to transform the x plus 5 to the other side. So I get 0 is equal to x squared. When I transform x, I'll get a 5x. When I transform my 5, I'll get a 4. Now I have a trinomial that needs to be factored. So I'm going to ask myself, what two numbers can I multiply, get a positive 4, combine and get a positive 5? That would be a positive 1 and a positive 4. So I'd have the binomial x plus 1 times the binomial x plus 4. I'm going to use the zero product property and take each one of these factors and set them up to be equal to 0, separated by the word or. So I end up with x is a negative 1, x equals a negative 4. Now I'm going to check to see if both of these numbers will satisfy this equation. When I substitute the negative 1, I'll have a negative 1 plus 5, which is 4, and the square root of 4 is 2. A negative 1 plus 3 gives me 2. 2 equals 2 is true, so that x equals negative 1 satisfies the problem. Let's see if the negative 4 satisfies the problem. If I put a negative 4 right here, I'll get a negative 1. And when I get the square root of whatever this is, it will never be a negative 1. But let's substitute so I can prove it to you. A negative 4 plus 5 is 1, and the square root of 1 is 1. So I'll have 1 equals a negative 1. That is not true. So this negative 4 is not a solution. The solution for the problem is x equals negative 1. This negative 4 is called an extraneous solution. The extraneous solution is a negative 4. That negative 4 will not satisfy the problem. Example 3. If I had 5 times the square root of m minus 3 plus 4 is equal to 14. The first step in this particular equation would be to transform the 4 to the other side, because again, I need to isolate this radical m minus 3. So I'm going to transform the 4 by using subtraction. Now this is read as 5 times the square root of m minus 3. That's multiplication. The inverse operation is division, so I'll take 10 and divide it by 5. So I get radical m minus 3 is equal to 2. I need to eliminate that radical symbol, so I will square both sides. When I square the radical, I get the radicand. The radicand is m minus 3. 2 squared gives me 4. Transform the 3, I get m is equal to 7. And again, let's check right quick. 7 minus 3 gives me 4. The square root of 4 is 2. 5 times 2 is 10, and 10 plus 4 gives me 14. So that m equals 7. 7 is my solution for the problem. Example 4. If I had the square root of the trinomial x squared plus 9x plus 15 and set it up to be equal to x plus 5. Again, I need to eliminate this radical symbol, so I will square both sides of the equation. Again, as I square this side, I will get the radicand, and the radicand is that trinomial, x squared plus 9x plus 15. When I square the binomial, square the first term, I get x squared, plus twice the product of these two terms. 5 times x is 5x, times 2 gives me 10x, and 5 squared gives me 25. If you notice, we have quadratic terms on both sides. If I were to subtract x squared from both sides, that will leave me with 9x plus 15 on the left-hand side. On the right-hand side, I have 10x plus 25. Solve for x. I'll transform the 9x by using subtraction. So I get 15 is equal to x plus 25. Again, I'm trying to isolate my x. Subtract the 25. I get a negative 10 is equal to x. Now, let's check to see if this negative 10 will satisfy the problem. I'll go right here. If I put a negative 10 in the place of x, I'll get a negative 5. When I get the square root of whatever it is that I have here, it will not be a negative 5. So that means that this will be no solution. This problem has no solution. Example 5. I had 6 times the square root of 5x divided by 4 minus 3 is equal to 0. The first thing I'll do is transform the 3. I will be left with 6 times the square root of 5x divided by 4 is equal to 3. I read this as 6 times. There's multiplication to undo it, divide, so I'll divide both sides by 6. As I do that, I'm left with 5x divided by 4 is equal to 1/2. To isolate the radical, to eliminate the radical, I'm going to square both sides. When I square this side, I get 5x over 4. Here I get 1/4. Remember, the quickest way to get rid of this coefficient of 5/4, multiply by its reciprocal, and I will show that multiplication for your benefit. That cancels, leaves me with x. That cancels, answers 1/5. And remember, take the 1/5, go back and substitute, see if it will give you a true statement. If it doesn't, then that means it would have no solution if that does not satisfy the problem. And our last example, example 6, if I have the square root of y minus 2 plus 4 is equal to y. Again, I need this radical to stand alone, so the 4 needs to be transformed to the other side. I'll subtract it. I need to get rid of the radical symbol. In order to get rid of the radical symbol, I'm going to square both sides. As I square the left-hand side, a radical squared gives you the radicand. The radicand in this case is y minus 2. As I square this binomial, square the first term, I get y squared. The product of these two is a negative 4y. Twice a negative 4 is a negative 8, so I'll have a negative 8y. Square the last term, I get plus 16. I have a quadratic term. I don't have a way to eliminate it. That indicates to me that I need an equation set up to be equal to 0. I'll transform the y minus 2 to the other side. So I'll get 0 is equal to y squared. As I transform the y squared, the y, I get a negative 9y. Transform the 2, I get a positive 18. Ask yourself, are there two numbers that I can multiply? Get a positive 18, combine, get a negative 9. That means that both numbers needs to be negative. So I'll have a y minus 3 times a y minus 6. Use the zero product property, set each one of those factors up to be equal to 0, separated by the word or. So I get y is equal to 3, y equals 6. We're going to check to see which one of these numbers will satisfy, or if both numbers. If I use the 3 minus 2 gives me 1, the square root of 1 gives me 1, and 1 plus 4 gives me 5, and then if I put the 3 there, I'll have 5 equals 3. That is not a true statement, so that means that y equals 3 is not a solution. It's an extraneous solution. I cannot use it. As I look at the 6, 6 minus 2 gives me 4. The square root of 4 is 2. 2 plus 4 is 6. Replace y with 6, I get 6 equals 6. So that is a true statement. So the solution for this particular equation is y equals 6.